I'm Dan Murphy, a volunteer at the Vintage Tech Museum. Tektronix oscilloscopes were used in medical research in the 1950s. The 564 storage oscilloscope was used to display ultrasound images of babies in the womb as early as 1965. Howard Vollum had written a memo in 1962 about his thoughts on developing a cathode ray electrocardiograph, or heart monitor, he called a cardioscope. Tektronix introduced the 410 Physiological Monitor, a battery-powered instrument for use in clinical medicine, in 1967. It would display an electrocardiogram known as an ECG, which displays the electrical signal of your heart. It could also display an electroencephalogram known as an EEG to display electrical activity in the brain. In late May of 1971, Howard Vollum suffered a heart attack. While recovering in the hospital, he knew Tektronix could develop even better medical products, and they did so with the introduction of the Model 414 portable patient monitor in 1976. The 414 shown here is a dual-trace instrument that simultaneously displays ECG and blood pressure or peripheral pulse and provides a digital readout of key measurements. Tektronix developed a number of other medical products, but sold the portable patient monitor business to the Squibb Corporation in 1980. Tektronix had great success with its oscilloscope plugins, which provided superb instrument flexibility. In 1973, they introduced a family of modular test and measurement products called the TM500 series. The mainframes were available in 1 to 6 slots, and there were well over 100 plugins available over the years. TM500 instruments enabled flexible configurations of many different test and measurement capabilities into a single instrument. They were used in general applications where flexibility was required, or for custom configurations that were used in manufacturing and service operations. Shown here are two TM504 instruments on a scope mobile. The upper TM504 is configured with a single-channel oscilloscope, a function generator, a digital multimeter, and a power supply. The lower TM504 is configured with a greater-featured dual-channel oscilloscope, a pulse generator, and a current probe. The TM500 family was superseded by the more capable TM5000 family in 1982. In the early 1960s, Tektronix began development of an electrostatic transmission electron microscope. This microscope was focused on low cost to compete in the educational market. The vertical column of an electron microscope is similar to a CRT, and Tektronix had great expertise in lens and CRT design. Competing systems were much more expensive, and the key feature of the Tektronix microscope was full automation. Operation of an electron microscope requires control of numerous gates, valves, and vacuum systems. The Tektronix electron microscope automated the process of controlling these devices to set up the microscope. The microscope featured a direct phosphor display which could be moved out of the way to capture images on 2-inch by 2-inch glass slides. Specimen numbers could be added to the edges of the images for easy reference. Tektronix chose to not productize the electron microscope. The development team spun out of Tektronix and formed a new company called Electros, with Bert Cathery as president. They completed the design and produced about 40 electron microscopes. A downturn in the economy in the early 1970s forced Electros out of business, but some of these electron microscopes are still in use. Shown here is Bert Cathery, who was the program manager for the development effort, recreating a pose he made with our No. 2 prototype, built in 1968. We have a cabinet of Tektronix Memorabilia on display at the museum. Some of the items include clocks, meters, pins, cookbooks, pens, anniversary medals, Howard's personal checks, frisbees, hats, patches, and a wide assortment of unique and one-of-a-kind items. One item on display is colored popcorn. Sometime in the 1950s, Tektronix was looking for a better way to cushion small products for shipping. Someone came up with the idea of using actual popped popcorn. A February 3, 1961 Tech Talk article describes the shipping popcorn. It was edible popcorn that had been colored blue-gray to discourage eating. It was less expensive than alternative packing materials. The way the story goes, the popcorn was in large bags hung from the ceiling in the shipping department. A woman was filling a box with popcorn when out came a dead rat. After composing herself and being frustrated with the situation, she picked up the evidence and marched over to Howard's desk but found him gone. She left the rat along with a note that said something to the effect of, "Fix this situation or find me a different job." The result was a U.S. patent for loose fill packing material issued in June of 1965 to Robert E. Holden and assigned to Tektronix. This cabinet and contents really has to be seen in person to experience all of the various items. Tektronix makes a great number of different analog and digital probes. These include general-purpose passive and active voltage probes, high-voltage probes, 50-ohm divider voltage probes, differential probes, passive and active current probes, and digital probes. A probe needs to extract minimal energy from the circuit under test and transfer it to a measuring instrument with maximum fidelity. John Kobe dealt with this issue, and he and Bill Politz came up with the idea of using a fine resistance wire as the center conductor of the probe cable. The 10th Tektronix patent for electrical probe was awarded on April 21, 1959, to John R. Kobe and William J. Politz. One probe that has been featured in a movie is the Tektronix P6000 series. This probe is used to check out the AE-35 unit in the 1968 film 2001: A Space Odyssey. Telequipment was a low-cost oscilloscope manufacturer located in Hoddesdon in the UK. Their equipment was primarily aimed at the television and repair service industry with low-cost and lower performance products. Tektronix was focused on engineering and scientific industries with higher performance and subsequently higher priced products. The enthusiasm of the successful acquisition of Pentrix and the formation of Sony Tektronix led to the acquisition of Telequipment in 1967 as a way to enter the low-cost market. The instruments retained the Telequipment logo but were marketed as a Tektronix subsidiary. Customers expected Tektronix performance, reliability, and quality and were often disappointed. Tektronix had developed their own lower-cost T900 series of oscilloscopes, and in 1978 the decision was made to terminate the Telequipment line. Tektronix leveraged the Hoddesdon facility and began to build Tektronix products on the site. This continued for another decade until the decision was made to transfer remaining production to the Heerenveen facility. A photometer is an instrument that measures the intensity of visible light. Tektronix made a number of photometers. This J15 photometer is unique in that Tektronix designed and manufactured it, but never sold it directly. The J15 photometer was designed to measure luminance levels in coal mines to meet new Mining Enforcement and Safety Administration regulations. It had to be rugged for that environment. Tektronix made them for mine safety appliances, who cataloged them and resold them to mining companies. The J15 is the only Tektronix product where the manual was printed on the instrument. The Tektronix 7104 was a revolutionary breakthrough oscilloscope, achieving 1 GHz performance, introduced in 1979. One of the key breakthroughs of the 7104 was the microchannel plate CRT, which was developed to significantly improve beam intensity at the high writing rate. While previous CRTs used distributed plates for the vertical deflection. The 7104 CRT used distributed plates for both the horizontal and vertical deflection. A microchannel plate is an electron multiplier device. Closely spaced across the plate are parallel 1 mm length channels, 25 microns in diameter, offset at a slight angle to the electron beam. The channel walls are coated with a material which exhibits secondary emission. When an electron from the CRT beam enters a channel, it strikes the wall, dislodging secondary electrons. These secondary electrons again collide with the wall, producing even more secondary electrons. The process continues, producing an electron multiplication of about 10,000, which produces a bright, sharp trace on the screen. The 7104 was named the Product of the Year by Electronics Products magazine in 1980. The T900 series were inexpensive oscilloscopes aimed at the education and service markets and were introduced in 1976. There were a total of 5 products in the family, starting with the 2-channel 10 MHz T912 up to the 2-channel with delayed time-based 35 MHz T935. These essentially displaced the telequipment line of low-cost oscilloscopes. These instruments had all plastic enclosures and were designed for portability, resulting in a long, narrow package. As such, they were affectionately referred to as Hoovers because of their similar appearance to the Hoover canister vacuum cleaner. Various models remained in production for nearly a decade. The 7612D is a programmable digitizer which required a high-performance analog-to-digital converter, which were unavailable in the late 1970s. Tektronix designed their own hybrid CRT semiconductor converter tube. Instead of a focused spot, the CRT produced a wide ribbon beam. Instead of a phosphor screen, the beam struck a semiconductor array of diodes. The diodes were arranged in rows, and the row struck by the beam could then be read digitally, resulting in analog-to-digital conversion. The resulting instrument was the 7612D, which achieved a vertical bandwidth of 80 MHz with a rate of 200 million samples per second. The 7612D contained 2 of the revolutionary T7612 hybrid tubes and cost $25,700, just over the average annual salary in the United States. The museum has a 7612D, which required careful restoration to return it to operation. Oscilloscopes needed to be close to the device under test. But there are some applications, such as nuclear research, where this isn't possible. The 7912 Transient digitizer, introduced in 1973, could drive a remote television-type raster display. It achieved a bandwidth of 500 MHz with a 7A19 vertical amplifier plug-in and 1 GHz bandwidth by accessing the CRT deflection plates directly with a 7A21N plug-in. The 7912 uses a scan converter tube, which looks similar to 2 CRT necks connected back to back. The writing gun consists of a traditional CRT gun that writes onto a silicon array of diodes in the middle of the tube. The charge is retained by the diode. The reading or scanning gun is on the opposite end, and the diode array can be read by scanning it with an electron beam. The charge was erased by this process of scanning. These instruments were used in significant quantities in nuclear and electromagnetic research and investigations. A system consisting of 26 7912s was installed at the Air Force Weapons Lab Trestle site for evaluation of electromagnetic pulse susceptibility. Other systems were deployed in trailers for nuclear testing and research. We have several stories of these systems on the website. The 11K series of oscilloscopes replaced the 7K series in 1986. The user interface uses a touch screen and menu system, so there are fewer controls on the mainframe and plugins. The 11301A had 400 MHz bandwidth with a high-resolution standard CRT. It features an internal 500 MHz universal counter timer that provides precise measurement of frequency, period, width, ratio, totalize, and time between events. Two unique features of the 11301 are histogram-based measurements and video signal features for easier measurements. The 11403 is a 1 GHz digitizing oscilloscope introduced in 1989. It is the first Tektronix oscilloscope to feature a color display. The use of color helps to delineate the various waveforms on the screen, as the oscilloscope was able to display up to 8 traces. The oscilloscope featured automatic measurement capability, which could be used in automated testing applications. Tektronix produced a number of plugins, transducers, and sensors to expand their oscilloscope market. The 7J20/J20 is one such instrument used to characterize the intensity and wavelength of ultraviolet, visible, or infrared spectrum. Its rapid scan capability can measure and record spectral information of events with durations of only milliseconds. It was introduced in 1975 and only remained in the catalog for a single year. Its $12,000 price in 1975 is equivalent to over $50,000 today. Our 7J20/J20 exhibit is set up with a color-changing LED bulb which displays the wavelength spectrum on the screen in real time.
I am Lauren Fletcher, Vintage Tech volunteer and treasurer. In the mid-1980s, Tech Labs launched a color research project. There were many color devices available and on the drawing board at this time. High-resolution color devices weren't available, especially with any appreciable tonal range. Printers had only 7 primary colors, and color computer displays were limited to 16 colors. Tech Labs built this system with 512 by 512 resolution. The cost of the memory at the time was over $50,000. The research investigated the best way to render a continuous tone image on a device which had a limited number of colors. Several methods of dithering were studied along with trade-offs of resolution and tonal range. Other parts of the research involved the human factor on the perception of color. One fact was revealed is that detail finer than the device resolution can be interpreted correctly by the brain if it's presented properly. An example is that a dim line will look thinner than a bright line. The imaging research group in Tektronix Labs had developed a liquid crystal color shutter. The shutter was used to provide frame sequential color using monochrome displays, but work had progressed for it for stereo 3D displays. The chemical modeling market seemed to be a good application fit for a 3D display. This effort was spun out of Tech Labs in 1988 and became the Cache Group. In 1989, they introduced the Cache Work System using a Macintosh computer with a fast coprocessor card and a liquid crystal color shutter. By 1991, this group was spun out of Tektronix and became a wholly owned subsidiary named Cache Scientific, Inc. The museum has a working Cache work system on display and the glasses to view the image in 3D. The Tektronix 7704 is a 150 MHz oscilloscope introduced in August 1969. The mechanical package was designed as 2 separate modules consisting of a top display unit and a bottom plug-in unit. A P7000 digitizer could be added between these modules to digitize the signals for processing on an external computer. The complete system was called a digital processing oscilloscope. Our 7704A on exhibit at the museum is demonstrating a different capability. It is configured with a 7L12 spectrum analyzer and 2 time bases. One time base is configured for the horizontal frequency, the other for the vertical frequency of an analog television signal. The spectrum analyzer is modulating the beam brightness, and the result is an oscilloscope which displays live analog television signal, albeit upside down. The 4100 series were low-cost color terminals introduced in 1983 as a replacement for the low-end DVST terminals. The 4200 series terminals were even at a lower-cost version to replace the 4100 series. While the resolution of these terminals were lower than the DVST, they were full color and used refresh technology. It was no longer necessary to erase the whole screen when something needed to be changed or be modified. They were compatible with Plot 10 software, a package that was in high usage by the scientific/engineering disciplines. The 4100 series was codenamed Unicorn. Key products were the 4105 with 480 by 360 resolution, a bit more than half VGA mode, the 4107 with 640 by 480 or VGA resolution, and the 4109, a 19-inch display version of the 4107. A companion 4170 local graphics processor, a multi-user CP/M computer, was also available as part of the family. Tektronix developed color printing technology in the early 1990s using a proprietary solid wax ink. The phaser name was derived from the fact that the solid ink was melted and went through a phase change. It was then ink jetted as a liquid and solidified on the paper. This provided much higher print quality than the conventional inks of the time and permitted the key advantage of printing on a wide variety of media. The Phaser 340, introduced in 1995, set a new standard for plain paper printing with high color quality and print speed. The print engine featured a page-wide print head, offset drum, and transfer roller. This unique printer was an early production unit. It was signed by the development team and presented to the project manager, Jim Rise. The 2400 series was Tektronix's most advanced line of analog oscilloscopes. They were analog in the sense that the signal path from input to CRT was analog with digital assistance. A microprocessor generated on-screen readout and cursors and performed auxiliary functions such as auto setup and automatic measurements. The front panel controls were read by the microprocessor and then drove the various analog circuits. As a way to further reduce cost, the development team experimented with front panel switch technology to replace the more expensive knobs and controls. This prototype oscilloscope was built by retrofitting a production unit with a new front panel and modified firmware for a knobless or nearly so oscilloscope. The concept was never developed further, so this is a one-of-a-kind instrument. Tektronix began working on digital or automated test systems in the mid-1960s. Earliest systems were used at Western Electric in Chicago and IBM wafer manufacturing facility in California. These automated test systems grew in size and complexity to address the semiconductor manufacturing markets. This S3280 system was introduced in 1979. In 1990, Semiconductor Test System was sold to Credent System Corporation. We have no semiconductor test system at the museum. We know of no system still in use, and their size and complexity are too large for our facility. We do have a number of articles, history, and photos on our website, including photo signs displayed at the 1989 International Test Conference. For years, Tektronix oscilloscopes were the primary instrument used to verify and service mainframe and many computers. The Tektronix 310 was a standard IBM service tool, being small enough for IBM service engineers to carry to customers' premises. The 453 oscilloscope was designed to fit under the seat on a plane to meet these portability requirements. It was realized that specific test aids were needed for digital systems. A portable test aid was specifically requested by and developed for burros. The need was only for 50 units, so Tektronix reused existing tooling for the 200 series mini scopes. This unit became the 850 Tech Aid, which the museum has. A more capable 851 instrument was also developed for burros. The 851 digital tester first appeared in the April 1978 catalog. The instrument shape was designed to either sit on top of a computer rack with the display pointing down or on a table with the display pointing up. It was designed for field service of digital equipment and has 22 different functions. It originally sold for $2,055 and was produced until 1983. The 7250 Transient Digitizing Oscilloscope represents the peak bandwidth achieved by an analog oscilloscope at 6 GHz. It uses a scan converter CRT to acquire and digitize the incoming signal. This immense oscilloscope weighs 132 pounds and is 36 inches deep. It requires a pre-trigger of 50 nanoseconds or an optional delay line in order to view the signal. It was designed, manufactured, and sold by Intertechnique of France as the IN7000. Tektronix rebranded and introduced it in 1986. Applications for the 7250 included particle physics research, where the requirement is to analyze non-repetitive high-voltage fast rise narrow pulses. Another application is to capture transient electrical phenomena for high-power laser research. Tektronix developed and produced charge-coupled device imagers known as CCDs in the 1980s as part of their integrated circuits operation. Tektronix was chosen to design and supply CCD imagers for the Space Telescope imaging spectrograph aboard the Hubble Space Telescope. Unfortunately, a significant flaw in the mirror construction prevented proper telescope operation. The Tektronix CCD imagers were swapped out as part of corrected optics, and the instruments installed in 1993 to compensate for the mirror flaw. In 1993, the CCD group was spun out of Tektronix to form Scientific Imaging Technologies, which continued to develop CCD technology. Their imager was installed on the Hubble Space Telescope in 1997. Thus, technology developed at Tektronix found its way onto the Hubble Space Telescope twice. Tektronix has had a long history of deep partnerships with universities. In 1951, Tektronix began to donate oscilloscopes to educational institutions. The Tektronix Foundation was formally established in May of 1952 to manage charitable donations. In 2000, Tektronix agreed to fund the start of a program called TechBots at Oregon State University with a grant of $500,000. The program was intended to give students a hands-on experience in their freshman year and give them opportunities to increase their design, troubleshooting, and teamwork skills. As they took engineering courses and learned new technologies, they would augment their TechBot with new technology. A course in DSP would lead to cameras and vision processing, while a class in RF might lead to wireless communication and control. The TechBot program was a wild success and soon expanded to other departments and other universities worldwide. Our final exhibit in this video tour is our remote exhibit booth. In support of STEM, we take hands-on exhibits for display at local STEM events. This particular event was the University of Portland's Reading Fair and Family STEM Day held in early 2020. We have a number of hands-on exhibits at the museum. This exhibit consists of 3 of our more popular and portable displays. On the left is our time of flight exhibit, which measures the velocity of a marble rolling down a chute on a storage oscilloscope. The chute has different angles to show different velocities. In the middle is our table tennis exhibit, where two individuals can play table tennis on an oscilloscope. On the right is our scope artist exhibit, where individuals can turn 9 knobs and operate 4 switches to make intricate geometric displays on the oscilloscope. Younger visitors will play with these exhibits for considerable time. These remote exhibits are quite enjoyable for all, and we look forward to when they will be held again. Thank you for watching our video tour of the museum. We hope you enjoyed the tour. All of these exhibits are on the website, along with over 80 movies, numerous company promotional material, newsletters, photos, and more. One of our more popular pages is our Tektronix in Movies and Shows, where we identify movies that use Tektronix instruments as props. Visitors to the site continue to send in more sightings. Our thanks to Tektronix for hosting the space for the museum, and to our volunteers who make all of this possible. If you're interested in volunteering, please contact us. We do have some opportunities that do not require being at the museum. And of course, our thanks to those that support the museum with their generous donations. This is our 10th year of operation, and we look forward to many more. Our website is located at vintagetech.org.